Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. If you have not subscribed also to this channel, this is a good time to actually hit the subscribe button and engage with our videos, playlists, and all of the things that we do in the community section of this particular channel. So today we're going to be continuing on our series on matrix, and here we'll be talking about operations involving matrix. The first operation we're going to be looking at is addition. So you have two matrices A and B. How do you add them together? First thing that we notice is that addition for matrices is actually commutative. What does that mean? In normal mathematics, if you say 2 plus 3, that will give you 5. And if I say 3 plus 2, that will give you 5. It doesn't matter the order in which it is arranged. Whether the 3 comes first or the 3 comes second, you're going to get the same answer. The same thing applies to a matrix. So if I have a matrix A and a matrix B, it does not matter if I say A plus B or B plus A, the results will still be the same. For addition to actually occur in matrices, both of them must be of the same dimensions. So you remember we talked about order in the previous video. We said if I had a matrix, it could be either a 3 by 3 matrix, a 2 by 3 matrix, a 2 by 2 matrix. If I want to add two matrices, both of them must be of the same order. So I cannot add a 2 by 2 matrix with a 3 by 3 matrix. That will not work. Both of them must be either 2 by 2 or 3 by 3 or 2 by 3 for the addition to actually occur. How do we now add? Each element of the sum is the sum of the corresponding elements of the original matrices. This particular point will be made visible with the use of an example. But just note that the sum of the matrix is the sum of the corresponding elements of the original matrix. Let's look at an example. It says that if A is equal to 1, 2, 3, 4 and B is equal to minus 2, 8, 5, 3, we should find A plus B. So to solve this, the resulting matrix will be A plus B. So if I do this my brackets here and I do this my brackets here, we said that it's going to be the sum of the corresponding elements. The first of them is going to be the sum of the first of the matrix A and the first of the matrix B. So when I say first, I'm talking about A11. I'm talking about how to denote this is A11, this is B11. So the sum of the elements in the first row and the first column of this resulting sum will just be 1 plus minus 2. Same thing, so I'll say 2 plus 8, that is A12 plus B12. For me to find this third guy, it will be 3 plus 5, and the last guy will be 4 plus 3. This shows that to find the sum of the matrix, we're going to be taking the sum of the corresponding elements in each of the matrix. If I sum this, 1 plus minus 2, this will give you minus 1, 2 plus 8 will give you 10, 3 plus 5 will give you 8, 4 plus 3 will give you 7. This is the results of our addition of matrix A and B. Subtraction. Unlike in addition where you say A plus B is equal to B plus A, in matrices, A minus B is not equal to B minus A. This is also the same thing that happens to in normal mathematics. So I could say 3 minus 5. 3 minus 5 is minus 2. But if I swap it and I say 5 minus 3, that will give you what? That will give you 2. You can see that the two values are not the same. In matrices, for you to subtract two matrices, they must also be of the same dimension. And then each element of the difference is the difference of the corresponding elements of the original matrices. Same thing as in addition, but this time it's just taking the difference instead of taking the sum. Let's look at this example. We have our matrix A 1, 2, 3, 4 and our matrix B minus 2, 8, 5, 3. We want to find A minus B. A minus B will just be equal to, so if I do a big bracket, this will be 1 minus minus 2. 1 minus open brackets minus 2. This will be 2 minus 8. This will be 3 minus 5. This will be 4 minus 3. Very simple. So we know that 1 minus minus, so this is the same 1 plus 2. This will be 3. 3 minus 5, this should be what? Minus 2. 2 minus 8, this should be minus 6. And 4 minus 3 is 1. So this is the simple solution for subtraction. Scalar multiplication. Have you ever seen when you're taking your camera and you want to zoom into something? You know, when you use your hand to zoom into the screen, you'll be seeing that it is going times 2, times 3, times 4. As you're zooming in, it is focusing more on the picture, making it bigger, making something that was very far to be nearer and bigger. Same thing too happens in scalar multiplication. You have a matrix. You want to increase the zoom power. What do? You say times 2 or times 3 times 4. Same thing, but in this case, each of the elements of the matrix, you're just multiplying it by that zoom factor. So it says that we should multiply each element of the matrix by the scalar, which is a single number. If I have a matrix A and I said k times A, which is like maybe 2 times A, I want to zoom in 2 times. Each of the elements I'll multiply by the scalar. Let's look at an example. We have a matrix A, 3, 5, 8, 2. We want to find 3A. If I were to relate it to that camera example, we want to zoom into it times 3. What are we going to do? 3A would be equal to, I'll have to multiply each of the elements inside there by 3. That will be 3 times 3, 5 times 3, 8 times 3, 2 times 3. And if I do this, this will give me 3 times 3 is 9, 5 times 3 is 15, 8 times 3 is 24, 2 times 3 is 6. So these are a simple solution to this scalar multiplication. And all of these things, we'll see where it applies by the time we go ahead when we're talking about inverse of a matrix. Multiplication. How do we multiply two matrices? For multiplication to be defined, the number of columns in A must equal the number of rows in B. The order of multiplication actually matters. You can't say A times B and expect that you have the same answer as B times A. Although in mathematics, if you say 2 times 3, it will give you the same answer as 3 times 2. But in terms of matrices, it does not hold. Remember this first law that says that the number of columns in matrix A must be equal to the number of rows in matrix B, and we will see why. Let's look at an example. So if I have matrix A to be A, B, C, D, and I have matrix B to be E, F, G, H, let's solve this together. The first check is to see if the number of columns in matrix A equals the number of rows in matrix B. So we have 2 columns in matrix A and we have 2 rows in matrix B, so that's fine. For me to find the resulting guy, so if this is the resultant, let's say the resultant is I, J, K, L. Let's say this is the resulting matrix. I'm going to find I have to multiply the first row by the first column. This I and J is my row 1 of the resulting matrix. For me to find the first element in my row 1, remember I is the first element in my row 1, I have to multiply the row 1 of A with the column 1 of B. Let me take that again. I have to multiply the row 1 of A with the column 1 of B. For me to find the second element in the row 1 of the resulting matrix, I have to multiply the row 1 of A and the column 2 of B. So basically, to find everything that's at the top, I have to be using the row 1 in matrix A. So that matrix A, the row 1 there will just be, it will be either the first guy that will be multiplying with or the second guy, depending on the location of where I'm dealing with. If it's the value I want to get, I have to multiply row 1 by column 1. If it's the value J, I want to get that to multiply row 1 by column 2. Same thing too, if I want to find the bottom guy in the resulting matrix, I have to multiply the bottom guys in row A with the columns of row B. So if I want to find K, I multiply the bottom row, which is the row 2, with column 1. I'll find K. If I want to find L, I have to multiply row 2 of matrix A with column 2 of matrix B. We're going to see this in real life. So let's now put this into practice. I'm going to find the first guy. Because it's at the top, I'll multiply the row 1 with the column 1. So that will be A times E, then I'll add it plus what? B times G. For me to find the second guy, that will be A times F plus B times H. So let me close this guy. For me to find the first guy in the row 2, that will be C times E plus D times G. And for me to find the last guy, which is in row 2, column 2, I have to multiply the row 2 of A with the column 2 of B. That will be C times F plus D times H. So you can see that at this place, the bottom number I'm going to multiply in times E, times G, times F, times H. It's just depending on if we are at the top or we are at the bottom. And this is actually the results of this multiplication. Let's say another example that doesn't have to do with A, B, and C, and D. This says that if matrix A is equal to 3, 5, 8, 2, and matrix B is equal to 1, 2, 3, 4, we should find A times B. I will encourage you to actually pause the video and try it out yourself based on what we've done with the A, B, and C, D. Welcome back. Let's solve it together. A times B will be equal to, I will open up my brackets. For me to find the first guy, I will multiply the row 1 by column 1. That will be 3 times 1 plus what? 5 times 3. For me to find the second element in this resulting matrix, I will multiply the first row by the second column. That will be 3 times 2 plus 5 times 4. And that's it. For me to find the third element in this resulting matrix, I have to multiply the row 2 of A by the column 1 of B, and that will be 8 times 1 plus 2 times 3. And finally, I would say row 2 of A multiplied by column 2 of B to find the fourth element, and that will be 8 times 2 plus 2 times 4. So if I close this, and this will give me 3 times 1 is 3, plus 5 times 1 is 15, 3 times 2 is 6, plus 5 times 4 is 20, 8 times 1 is 8, plus 2 times 3 is 6, 8 times 2 is 16, plus 2 times 4 is 8. So let's add. 3 plus 15 is 18, 8 plus 6 is 14, 6 plus 20 is 24, 16 plus 8 will give you 24. 6 plus 20 is actually not 24, it's 26. Let me correct that, 26. So our resulting matrix is 18, 26, 14, 24. Let's see if we're correct. 18, 26, 14, 24. So if you got this, well done to you. This other example says that if A is equal to 362, 124, 36 minus 4, and B is equal to 204 minus 134, 321, we should find A times B. This is very, very tricky, right? It's actually more complex than the first example or the previous example, but let's solve it together. A times B here, it will be equal to, the first thing we need to check is that the number of columns in the first matrix is equal to number of rows. So we have 1, 2, 3 columns, and we have 3 rows. Fine, we're good. If we cannot proceed, we will just say that we cannot proceed because number of columns in A is not equal to number of rows in B. You give your reason. So to find the first element, that will be 3 times 2 plus 6 times minus 1 plus 2 times 3. Same principle. To find the second element, that will be 3 times 0 plus 6 times 3 plus 2 times 2. And to find the third element, that will be 3 times 4 plus 6 times 4 plus 2 times 1. And that's it with the row 1. For the row 2, same thing too. Row 2 multiply column 1 of the matrix B. That will be 1 times 2 plus 2 times minus 1 plus 4 times 3. Also 2, row 2 multiply column 2. That will be 1 times 0 plus 2 times 3 plus 4 times 2. And finally, for the last guy, that will be 1 times 4 plus 2 times 4 plus 4 times 1. And finally, for the last row, let me close this matrix. The last row, we'll say 3 times 2 plus 6 times minus 1 plus minus 4 times 3. And then for the middle one, we'll say row 3 times column 2, which is 3 times 0 plus 6 times 3 plus minus 2 times 4. And then for the final guy, we'll say row 3 times column 3, which will be 3 times 4 plus 6 times 4 plus minus 4 times 1. Now let's now simplify this. I'm just going to add all of them together because of time. If I resolve the first guy, that will be 3 times 2 plus 6 times minus 1 plus 2 times 3. That will give me 6. The second guy will give me 3 times 0 plus 6 times 3 plus 2 times 2. That gave me 22. And the last guy would be 3 times 4 plus 6 times 4 plus 2 times 1. Give me 38. So I'm done with row 1. Row 2 will be 1 times 2 plus 2 times minus 1 plus 4 times 3. That will give me 12. Second guy will be 1 times 0. If I will just ignore the first guy because 1 times 0, 3 times 0 will give me 0. So that will be 2 times 3 plus 4 times 2. And that will give me 14. And 1 times 4 plus 2 times 4 plus 4 times 1. That will give me 16. And the final that will be 3 times 2 plus 6 times minus 1 plus minus 4 times 3. That will give me minus 12. 3 times 0 is 0. So that will be 6 times 3 plus minus 4 times 2. This gave me 10. And finally, 3 times 4 plus 6 times 4 plus minus 4 times 1. This gave me 32. It's possible that one of the values is not correct, but let's see. So by the time we multiply this A times B, we had this value. And you can see the principle still remains the same. Row against column, row against column, row against column. This is why the number of columns in the first matrix must equal the number of rows in the second matrix. Let's see if the answer is correct. Great, our answer is actually correct. We did a good job. Now the next thing we're going to look at is how to find determinant of a 2 by 2 matrix. To find determinant of a 3 by 3 matrix, 4 by 4 matrix is not really the same way. you have to, there's something you have to do, plus minus plus minus plus minus plus minus plus, but that's a bit advanced and that's beyond the scope of WAEC. We're restricting ourselves to the scope of WAEC. For a 2 by 2 matrix, to find determinant, you first have to express it as this, as a straight line, the name of the matrix, and a straight line. If I see this, I know that you're talking about determinant of the matrix. So this is how you should annotate determinant of a matrix. To obtain the determinant of a 2 by 2 matrix, subtract the product of the elements in the second diagonal from the product of the elements in the leading diagonal. So what does that mean? Look at this example. We have matrix A, which is A, B, C, D. This diagonal here is the what? Can you guess? Great, is the leading diagonal. And this other diagonal here is the other diagonal. So it's saying that we should subtract the product of the elements in the second diagonal. The second diagonal here is the other diagonal. So I will do B times C. I have the products. I'll subtract it from the product of the elements in the leading diagonal. That will be A times B. So that will be A times D minus B times C. And that will give me determinants. So you can see the determinant of this is A times D, which is the product of the guys in the leading diagonal, minus the product of the guys in the other diagonal. So that is AD minus BC. Let's solve a real life example. We're told that if matrix A is equal to 3, 5, 8, 2, let's find the determinant of A. I'm not going to solve this. I want you to solve it by yourself. Welcome back. Your answer should be 3 times 2 minus 8 times 5. And 3 times 2 is 6. Minus 8 times 5 is 40. So 6 minus 40, that should give you what? Minus 34. It's a very simple thing. Another example is saying that if B is equal to 3, 1, 4, 2, we should find the determinant of B. Solve this by yourself. Welcome back. So that will be 3 times 2, which is 6, minus 1 times 4, which is 4. So 6 minus 4 is equal to 2. So your answer here should be equal to 2. If you got both questions right, well done to you. Now, all of things that we have been doing, all the multiplication, the determinant and everything, is bringing us to this point called inverse of a matrix. First off, when you hear the word inverse, what does that mean? Inverse means reciprocal. So if I say the inverse of 5, I'm saying 1 over 5, or 5 raised to the power of minus 1. Also too, if I have a number and I multiply by the reciprocal, it will give me a value of 1. So if I say 5 times the inverse, which is 1 over 5, I will have the value of 1. Likewise, also in matrices, the product of a matrix and its inverse is the identity matrix. So if I have a matrix A and it's a 2 by 2 matrix and I multiply by the inverse of it, I'm going to have an identity matrix. And we've talked about identity matrix in the previous videos. So that will be 1, 0, 0, 1. Identity matrix is a matrix that has value 1 only in the leading diagonals, and every other value around it is 0. So if you multiply a matrix and its inverse, you should be able to have an identity matrix. This is another way of proving if your answer is actually right. So if you find an answer at the end of the day and it's the inverse, you say this is the inverse, so multiply it by the original matrix that you have. If you don't have an identity matrix, then you must have missed the step and you will trace a stop. How do we find the inverse of a matrix? If I have a matrix A, which is A, B, C, D, first thing is that I will have to find the determinant of the matrix. We know how to do this. Second thing is that I will interchange the top left and the bottom right elements. Remember, all of this just applies for a 2 by 2 matrix. For a 3 by 3 and 4 by 4 matrix is more complicated than this. So the step 2 is that I will change the guys in the leading diagonal, interchange the elements in the leading diagonal. So instead of AD, I will have DA. Then the next step is that I will multiply the elements in the other diagonal by minus 1. So you can see the other diagonal. Previously it was B and C. I will multiply them by minus 1. So this becomes minus B and minus C. Then I will divide the resulting matrix by the determinant of the original matrix. So this is the resulting matrix. I'll just divide it by determinant. You know, if I had 5 over 2, it's like saying 1 over 2 times 5. So the same thing. So if I had this matrix divided by AD minus BC, it's like saying 1 over AD minus BC multiplied by D minus B minus C and A. This is a simple way to find the inverse of a matrix. And you'll be wondering, what is this inverse of the matrix used for? If you have all these equations where you have a simultaneous equation, you have equation 1, you have equation 2, they tell you to find x and y. You can use this inverse of a matrix to actually solve those kind of equations. Now, there is a caveat. If your determinant of your matrix is 0, then that means that this particular question does not have an inverse. So note that if the determinant of your matrix is 0, it has no inverse, since division by 0 is impossible. Note that, please. Let's see a good example. So this example is saying that we should find the inverse of 2538. Let's call this A to be 2538. The step 1 is to find the determinant. Quickly solve that and tell me what your answer is. Great, your answer is 1. Yeah? How? First thing I'll say straight line A, straight line will be equal to 2 times 8 minus 3 times 5. So 2 times 8 is 16, 3 times 5 is 15, 16 times 15 is 1. Well done. Then in step 2, who can remind us what step 2 is? Great. So I'll just say interchange the values on the leading diagonal. So it will now become 8, 2, 3, 5. Now step 3 is what? Who can remember? Great. So multiply the values on other diagonal by minus 1. So this would be, what is the other diagonal? This is the other diagonal. So I'll still maintain this my 8 and 2, but instead of saying 5 and 3, I'll say minus 5 and minus 3. This is the resulting matrix. So step 4 now says that we should divide the resulting matrix by determinant. So divide resulting matrix by determinant. If I were to solve this question in WAEC or for my school exam, these are actually state everything: step 1, step 2, step 3, step 4. Because you don't want to make your lecturer or your teacher or your external examiner to assume what you are doing. I'll say A inverse is equal to 1 over determinant is 1, and our resulting matrix is 8 minus 5 minus 3 and 2. Luckily, anything you divide by 1 is the same value. So 1 divided by 1 is 1. If I multiply this 8 minus 5 minus 3 and 2 by 1, which is scalar multiplication, it's still going to remain the same thing. So you can see the application of scalar multiplication here. So our A inverse is just 8 minus 5 minus 3 and 2. So that's it. Let's see if our answer is correct. 8 minus 5 minus 3 and 2. This example now says that given that m is equal to 1, 2, 4, 3, n is equal to mx, ny, and mn is equal to 2, 1, 3, 4. Remember the order is m times n. Find the matrix n. I want to pay attention to all these examples that we're doing because we're not solving WAEC past question. Nobody will always do that. I'll do a video on WAEC past question. WAEC past questions on matrices for the last 10 years was very hard to come by. This is from WAEC 2017. I want to pay attention to all these examples. There are different ways that you can be able to do this. You could say m times n, then you do simultaneous equation and find what m n x y is. But I'll rather use the inverse operation to find this. So I know that m times n is equal to mn. Let's say mn is, instead of saying mn, let's say mn is product. Let's call it product. So m times n is equal to product. If I wanted to find what n is, I would divide both sides by m. M will cancel m. So our n will be equal to product divided by m. How else can we say this? You can say n is equal to m inverse multiplied by the product. So here we are going to find the inverse of m. When we find the inverse of m, we'll now do multiplication with the product. This is actually a very good question. Let's find the m inverse. Step 1 is to find determinant. I'm not going to write all of that, but our value is 1, 2, 4, 3. So determinant of n would be, let me put, so this is 1 times 3 minus 2 times 4. This 1 times 3 is 3, 2 times 4 is 8, 3 minus 8 is minus 5. So our determinant is minus 5. Step 2, what do we say step 2 is? Great, we'll swap the values in the leading diagonal. So this would be 3, 2, 4, 1. 3, 2, 4, 1. Great. And our step 3, where's our step 3? Great. Multiply the values in the other diagonal by minus 1. So this would be 3 minus 2 minus 4 and 1. So imagine if I was not writing, I'm not writing the step I'm doing. It looked like jargons to my lecturer or to my teacher or to my examiner. That is why you have to write exactly what you are doing, like I was doing in the previous examples. Because of time, I'm not writing all those things. The last step is that you divide the resulting matrix by the determinant of the matrix. So that would be m inverse would be equal to 1. I made a mistake here. I said determinant of m. This should be determinant of m. This should be m, not n. Pardon me. So this would be 1 over determinant of m multiplied by 3 minus 2 minus 4 and 1. So what is determinant of m? Determinant was minus 5, if I'm correct, minus 5, and this is 3 minus 2 minus 4 and 1. I would advise that you don't do the multiplication yet because it can get very messy. So instead of saying minus 3 over 5, 2 over 5, 4 over 5, minus 1 over 5, that would be very messy. Just leave it like this. So the next thing that we'll substitute, we already have the m inverse, so we can substitute into this formula and say n, which is equal to m inverse multiplied by product. Our m inverse is 1 over minus 5, open brackets, 3 minus 2, minus 4 and 1. And then the product, where is the product? Product is what? 2, 1, 3, 4. 1, 3, 4. I want you to multiply these two matrices. Welcome back. Let's do it together. So 1 over minus 5, I will open this bracket. 3 times 2 plus minus 2 times 3. And then 3 times 1 plus minus 2 times 4. So we're done with that. The bottom will be minus 4 times 2 plus 1 times 3. And this will be minus 4 times 1 plus 1 times 4. This would be 1 over minus 5. 2 times 3 is 6. Minus times plus is minus. 2 times 3 is 6. 3 times 1 is 3. Plus times minus is minus. 2 times 4 is 8. Minus 4 times 2 is minus 8. Plus 1 times 3 is 3. Minus 4 times 1 is minus 4. Plus 1 times 4 is 4. So this is 1 over minus 5. Open bracket. 6 minus 6 is 0. Minus 8 plus 3 is minus 5. 3 minus 8 is minus 5. Minus 4 plus 4 is 0. If I'm too fast, you can actually pause the video, rewind, or reduce the speed of the video. Now, is it not easier for me to now multiply each of these guys by 1 over minus 5? Yes, it is way easier. So if I do that, that will be 0 times 1 over, or let's say minus 1 over 5, minus 5 times 1 over minus 5, minus 5 times 1 over minus 5, 0 times minus 1 over 5. Anything multiplied by 0 is 0. Minus 5 will cancel minus 5. Minus 5 will cancel minus 5. So I'm left with what? 0, 1, 1, 0. So this is the answer of our n. That means that our m is 0, our x is 1, our n is 1, and then our y is 0. This is actually how you solve this type of question. I like that it encompasses everything that we have done. Let's see if our answer is correct. 0, 1, 1, 0. Great. And you can also do the manual multiplication by yourself. Do m and n with this new value and see if we're going to have these results. Like I said, a very good importance of the inverse of a matrix, of a 2 by 2 matrix, or any matrix that it can be used to solve simultaneous equations. So let's see an example of that. We're told to solve the equation 3x minus 4y is equal to 1 and 7x plus y is equal to 23 using matrix. So to solve this question, first things first is that we know that our equation 1 is 3x minus 4y is equal to 1. So this is our equation 1. And then 7x plus y is equal to 23. These are equation 2. The thing that we do is that we take the coefficients of each of these values. So if I open up my first bracket, the coefficient of x in this place is what? Is 3. We'll write it down. The coefficient of y is what? Some people say it's 4, but it's actually not 4. It's actually the minus and the 4. So that will be minus 4. Coefficient of x in this place is what? 7. Coefficient of y in this place is, someone will say that there is no coefficient, but you can say 1 times y is the same as y. So we can just say the coefficient is what? 1. So we put all the coefficients inside a matrix. Followed by, what are the variables that we have? We have variables x, we'll put that one here. We have variable y, we'll put it under. And then is equal to the solution. What is the solution? Solution is 1 and 23. Look at something. If I were to do this multiplication, you agree with me that I will have this guy back. So let's say 3 times my x, that will give you 3x. Plus minus 4 times y, that will give you minus 4y. 7 times x, that will give you 7x. And then 1 times y, that will give you plus y. So it's the same thing. These are actually break it up apart. Now that we have that, if I wanted to find x and y, if I say that this matrix is A and this matrix is B, just for emphasis purpose, I would say A times xy is equal to B. If I wanted to find what this x and y is, I would say xy is equal to b over a. Is that not it? I will divide both sides by a. Now if I do that, I can now say xy is equal to, instead of saying b over a, you can say what? A inverse multiply this by b. So you can see that for us to find what this x and y is, we need to find the inverse of a and multiply by b. So let's solve for a inverse. I actually wanted to pause the video and solve for this a inverse. Welcome back. So our a is 3 minus 4, 7 and 1. Remember, we are doing everything in steps, and I wanted to write the definition of what each steps are, but I won't do that because of time. So the first step is determinant. That will be 3 times 1 minus, open brackets, minus 4 times 7. 3 times 1 is 3, minus as minus is plus. 4 times 7 is 28. 3 plus 28 is 31. So we know that our determinant is 31. Then the step 2 is to interchange values on the leading axis. That will result in 1, 3 minus 4, 7. Once again, write what you are doing. Don't let the lecturer assume, or the supervisor, or the class teacher. So step 3 is negate the values on the other diagonal. So this will be 1 minus 4 times minus 1 will give me plus 4. 7 times minus 1 will give me minus 7, and then this 3. So this guy is set. Then our step 4, which is the final step, I would divide the resulting matrix from step 3 by the determinant. Determinant is 31. So that would be 1 over 31, open brackets, 1, 4, minus 7 and 3. Like I said before, don't expand this. Don't do that scalar multiplication here. You will just complicate things for yourself. Now that we have that, I can say substituting xy will now be equal to 1 over 31, open brackets, 1, 4, minus 7 and 3, and I think it's multiplied by b. What is our b? Our b is 1 and 23. So it will multiply this guy, which will be 1 and 23. So we said that for multiplication to occur, the number of columns in the first guy must equal to the number of rows in the second guy. So how many columns do we have? We have column 1, column 2. We have 2 columns. How many rows do we have here? We have row 1, row 2. So 2 columns, 2 rows. Fine, we can proceed. If I were you to score an extra point in the exam, I would say since the number of columns in the first matrix in brackets 2 is equal to the number of rows in the second matrix in bracket 2, the multiplication can proceed. Just some small things like that can make you earn extra points. So this will be 1 over 31, open bracket. So this 1 times 1 plus 4 times 23. We are done with this guy. And then minus 7 times 1 plus 3 times 23. So let's see, this 1 over 31. 1 times 1 is 1 plus 4 times 23. What will 4 times 23 give you? That will give you 92. Minus 7 times 1, that will give you minus 7, plus 3 times 23 will give you what? It will give you 69. 1 plus 92 will give you 93. Minus 7 plus 69, that will give you 62. Now I can do the scalar multiplication on this small matrix. You can see it's actually very easy now. So that's like saying 93 times 1 over 3 and 62 times 1 over, so not 1 over 3, 1 over 31, 1 over 31. This is 1, this is 3, this is 1, this is 2. So this is 3 and 2. So we are saying our x and y, how much x and y is this guy. So if I just do comparison, so I could say by comparison, our x is equal to 3 and then our y is equal to 2. So this is how we can use inverse to actually solve a simultaneous equation. Let's see if our answer is correct. X is 3, y is 2. Well done. Now the last example I'm going to be treating is this particular one. It says using matrix, solve the equations 15s minus 6 is equal to 4 and 6s plus 18c is equal to 5. I actually wanted to pause the video and try this one out yourself. Welcome back. Let's solve it together. So the first thing that we'll write it down and say 15s minus 6c is equal to 4. This is equation 1. And then 6s plus 18c is equal to 5. This is equation 2. So we can say breaking into matrices. The coefficient of s is 15. Coefficient of t is what? Beautiful. Minus 6. Coefficient of s is 6. Coefficient of t is what? 18. After this, we'll put the variables, which is s and t, and then equal to the result is 4 and 5. I can say this is my matrix A, this is my matrix B. So S and C would be equal to A inverse multiplied by B, right? And I've showed you why. To find my A inverse, I would say step 1 is find the determinant, which is determinant. Like I always say, write what you're doing. I'll keep on saying it. That would be 15 times 18 minus open brackets minus 6 times 6. So what is 15 times 18? That gave me 270 when I pressed on my calculator. Minus times minus is plus. 6 times 6 is 36. So 270 plus 36, that will give you 306. So the determinant of A is 306. Then the step 2 is that we should do what? Interchange values in the leading diagonal. So this would be 18, 15, or 18 minus 6, 6 and 15. Then step 3 is to negate the values on the other diagonal. Once again, write it. 18, 15. If I negate minus 6, that will give me 6. If I negate 6, that will give me minus 6. And then the step 4, I can now say 1 over the determinant, which is 306, and multiply by the resulting value from the step 3, which is 18, 6 minus 6 and 15. Once again, don't expand these brackets here. We are done with this. We know that our A inverse is 1 over 306, 18, 6 minus 6 and 15. We are done with that. The next thing to do is now to substitute and say, oh, let's substitute this value so that we can find S and C. So substituting, S and C would be equal to 1 over 306, open brackets, 18, 6 minus 6, 15, and then multiplying what is our B? Our B is 4 and 5. So this is 4 and 5. Let's do the multiplication together. So that will be 1 over 306, open brackets, 18 times 4 plus 6 times 5. And then minus 6 times 4 plus 15 times 5. 1 over 306. What is 18 times 4? That will give you 72. I press that on my calculator. Plus 6 times 5. That will give me 30. Minus 6 times 4. That will give me minus 24. And then 15 times 5. That will give you 75. 1 over 306. 72 plus 3 plus 30. That will give me 102. And then minus 24 plus 75, that will give me 51. My S and C is here. But then I now have to now do the scalar multiplication. So S and C would be equal to, open brackets, 102 multiplied by 1 over 306, and then 51 multiplied by 1 over 306. This can go here 3, and this can go here, I think this can go here 6. So at the end of the day, I can write my S and C as 1 over 3 and 1 over 6. I can now say by comparison, S is equal to 1 over 3 and C is equal to 1 over 6. If you got this, well done to you. You've found out how to use matrices to solve simultaneous equation. And this is what we're going to be using going forward, just to make it stick in our head. Let's see if our answer is correct. S is equal to 1 over 3 and C is equal to 1 over 6. So that's it about matrices, inverse of a matrix. The most important thing about matrices is how to do an inverse of a matrix and is to solve questions like simultaneous equation. We have come to the end of all things matrix. Like I said, once again, there will not be any WAEC past question on matrices because there are not enough questions from the past 10 years to actually make a complete video. And the most recent one was from 2017. As far as I'm concerned, or as far as I checked, I might be wrong, and we've treated it as one of the examples. Bearing this in mind, we are closing the chapter on matrix. If you found this video useful, don't forget to like. The more you like, the more you encourage me to keep doing the videos, and the more you keep spreading the word. Tell somebody, invite somebody that you know can benefit from this channel. The more subscribers, the more likes, the more I'm motivated to continue what I'm doing. See you guys in the next video.